Hello students, welcome to new session again. Today we are going to start new chapter 14, electric current and its effects. In this chapter we will study about electrical energy, symbols of electrical components, electric cell, electric battery, electric circuit, resistance, effects of electric current and working of electric bell. Students, we know that electricity is very important source of energy and we use this electricity for lighting bulbs, tubes, operating fans, electrical appliances and for various other purposes. And this electricity is actually a form of energy, and this is known as electrical energy, and we use this electrical energy for operating many electrical devices and appliances, and this electrical energy is controllable and convenient form of energy. So in this chapter we will study about electricity and how electric circuit works and various components of electric circuits and effects of electric current in detail. First, let us discuss about symbols for electrical components. We know that we use different symbols, different components such as cells, bulbs and wires in an electric circuit. So these components are also known as elements of an electric circuit. And if you want to draw an electric circuit, so it would be difficult to make these diagrams of these components. So instead of actual diagrams of these components, we can use symbols. So that's why scientists, they have devised standard circuit symbols for electrical components, and these are universally accepted, and these are often used in the circuit diagrams, and this makes an electric circuit easy to understand. So here are the symbols of electrical components. First one is electric cell. This is the symbol for electric cell. This bigger line is showing positive terminal of the cell and smaller one is negative terminal of the cell. Then we have symbol for electric bulb, then switch in off position and switch in on position. Then this is the symbol for battery, means when we join many cells together, then it form battery, and wire can be represented by a simple line. So this is the symbol for wire. Next is electric cell. We know that electric cell is a common source of electric current to run a number of devices. So we use these electric cells to get electricity from these, and then these can run many electrical appliances such as torches, transistors, TV remotes, Walkman, electric clocks, electronic toys, etc. So every electric cell has a positive and a negative terminal. These terminals, they are clearly mentioned or printed on every cell, and many of these appliances use more than one electric cell. Now next is electric battery. Electric battery is combination of two or more cells. So when we combine two or more cells, it forms battery, and in a battery, electric cells can be connected in series as well as they can be connected in parallel. Now first let us discuss about cells connected in series. In this kind of battery, the cells are connected in such a way that the negative terminal of one cell is connected to the positive terminal of the next cell. And we can change number of cells. It depends upon in which the device in which we are using. So number of cells can be different in different devices. For example, in TV remote control, the two cells are placed side by side in a cell holder to make a battery. So in this case, the positive terminal of one cell is connected to the negative terminal of the other cell by a metal strip in the cell holder of the TV remote, and this way the cells are connected in series. So, moreover, in order to help us place the cells correctly in cell holder, the symbols plus and minus are also printed on the two sides. So, this plus symbol is for positive terminal and this minus symbol is for minus terminal. You must have seen car batteries. We use batteries in cars, buses and trucks. These batteries also, they have 6 cells in them, and these type of cells, they are storage cells. So these cells can be recharged, but the ordinary cells which we use in torches, etc., so these cannot be recharged. So once they get exhausted, they should be disposed of properly. Next is cells connected in parallel. When we connect cells in parallel, the negative terminal of all the cells are connected together with the help of wires. And similarly, the positive terminals of all the cells, they are connected together. So, we can use a cell holder to hold the cells in parallel. So, this diagram shows cells connected in parallel. Now let us discuss about electric circuit. So first we'll try to understand what is an electric current. The flow of electrons is called electric current, and the path along which this electric current can flow is called an electric circuit. So we can say electric current is the flow of electrons, and the path along with which this electric current flow, that is known as electric circuit. So we can say an electric circuit consists of following components. There should be a source of electric current. It can be a cell or it can be a battery. Then we have conducting wire, and then we have an electrical appliance and a switch. So all these are the components which form an electric circuit. Now electric circuit are also of two types: closed circuit and open circuit. Now let us discuss about closed circuit first. The electric path which starts from the positive terminal of a cell and ends at the negative terminal without any break, that is known as a closed circuit or complete electrical circuit. So here in this diagram you can see the circuit is complete. There is no break in the circuit, so it is complete electric circuit. So here the bulb will glow. Next is open circuit. The electric path which starts from a positive terminal of a cell and is broken at some point. So that type of circuit is known as incomplete circuit or an open circuit. So we can say here this circuit is not complete, it's open. So no current flows in such a circuit. So that's why in this circuit bulb will not glow, because it is incomplete circuit and there is break in the circuit. So current will not flow and bulb will not glow in the circuit. Next is circuit diagram. A diagram which shows the arrangement of various electrical components in an electric circuit with the help of their symbols is called a circuit diagram. So here in this diagram you can see first one is the circuit diagram of a closed circuit, and second diagram is showing an open circuit. So in first diagram, closed circuit, a switch is there, closed switch is there, and battery is there, and a bulb is glowing. So this shows a closed circuit, and if it is a closed circuit, so bulb will glow in this diagram in this circuit. And second diagram is showing open circuit means here the switch is open, that means circuit is incomplete. So this will be the open circuit, diagram of an open circuit, and here the bulb will not glow because this circuit is incomplete, it is open circuit. To understand open circuit and closed circuit, we can also perform an activity which can show that electric current flows in a closed circuit and it stops in an open circuit. So what we require in this activity, we need a cell, a switch, some pieces of copper wire, a bulb and bulb holder. So what we have to do, first we have to connect a positive terminal of the cell with one end of the wire, and then the other end of the switch is connected to one end of the bulb holder with another piece of copper wire, and the negative terminal of the cell is connected to the other end of the bulb holder with a copper wire. So here we can use safety pin, we can use which can act as switch, and when the switch is on, the position of the circuit means it's closed circuit. So in that case, if we try to observe, then when the switch is on means if the circuit is complete, so the bulb will close, and if the circuit is broken means if the switch is off, if we try to disconnect this safety pin, or if we try to break the circuit, so the current will not flow and the bulb will not glow. So we can understand this with the help of this activity, that current flows in a closed circuit and stops in an open circuit. Now next topic here we will discuss is resistance. We'll try to understand what is resistance. The property of a material by virtue of which it opposes the flow of electric current through it is called its resistance. Okay, so the lower the resistance, the greater is the current flowing. We can understand this resistance with the help of an example. As we know that whenever any object is moving on a floor, so that force of friction opposes the movement of any object. So same way this resistance also opposes the movement of electric current. So if the resistance will be low, so the current flowing will be higher. So we can say lower the resistance, the greater is the current flowing. Now as we have already discussed what is resistance, so depending upon the resistance, we can classify materials into two categories, conductors and insulators. And the materials like metals, they have very low resistance, so they conduct electricity well, so they are known as good conductor of electricity, or they can we can say conductors. And the materials like wood, plastic, rubber, these do not conduct electricity, so they are called insulators, and they have high resistance, so we can say these are insulators. Now next, let us discuss about effects of electric current. Electric current can produce three effects: heating effect, magnetic effect and chemical effect. In this class we'll study about heating effect and magnetic effect only. Chemical effect you will study in higher classes. Now first we will discuss about heating effect of electric current. As we have already discussed about resistance, so resistance can be compared with force of friction. So when an electric current passes through a high resistance wire, for example a nichrome wire, then the electrical energy is converted into heat energy, and this heats up the resistance wire. So this is called the heating effect of current, and this amount of heat produced depends upon two factors. First one is resistance of material, and second one is magnitude of current passed through the wire. Now first let us discuss how heat produced depends upon the resistance of material. So we know that resistance of any material tries to stop the flow of electric current. So higher is the resistance, the greater is the heat produced, and the lower is the resistance of the material, lesser will be the heat produced. So we can say if resistance is high, heat produced will be high or greater, and if the resistance is low, then heat produced will also be less. Heat produced also depends upon the magnitude of the current. So greater the magnitude of current passed through a given wire, so greater will be the heat produced in it. Now next is application of the heating effect of current. The electric heating appliances such as electric room heater, electric iron, water heater, all these appliances work on the principle of heating effect of current. These appliances, they contain a coil of high resistance wire which is known as heating element, and generally this coil is made up of a nichrome wire, nichrome alloy. It is an alloy, means it contains iron, nickel, chromium and magnesium. So when electric current is passed through this electric heating appliance, a large amount of heat is produced in the element, due to which it becomes red or hot. And then this heat can be used for many purposes. For example, the hot electric iron is used for ironing clothes, and the hot electric room heater is used for warming the room, and electric heater is used for cooking food also. So this way heat can be used, heat produced can be used for different purpose. Next is electric bulb. We know that we use electric bulb for getting light. So this electric bulb is used for producing light, and this also works on the principle of the heating effect of electric current. This bulb has a very thin high resistance filament, which is filament of tungsten metal. This tungsten filament, it gets heated to a very high temperature and it becomes white hot and it starts glowing. So this way it gives us light, it emits light. So but along with the light, heat is also produced. So an electric bulb also gives out heat, which is wastage of electricity. So to reduce this wastage of electricity, we can use LEDs and CFLs. LEDs means light emitting diodes, and CFL, these are compact fluorescent lamps. So nowadays we use these LEDs and CFLs for because these reduce wastage of electricity, and these bulbs do not work on the principle of heating effect of current. They do not have filaments, and they do not waste electricity. So that's why they are known as power efficient. And advantage of these CFL and LEDs are that they can also be fixed in ordinary bulb holders, and these are also very efficient and long lasting. And we should also check ISI mark of Bureau of Indian Standards on these appliances before buying these. So this was all about electric bulbs, how they work. Electric bulb work on the principle of heating effect of electric current, whereas LEDs and CFLs do not work on the principle of heating effect of current. Now next we will discuss here is electric fuse. You all must have heard this term electric fuse. Now what is this electric fuse? Electric fuse is a safety device which breaks the electric circuit when there is an excessive flow of current in the circuit. So it prevents damage to the electrical appliance and possible electric fire. So we can say this electric fuse works on the principle of the heating effect of current. So in this electric fuse, it is a piece of thin wire. Generally, this wire is of an alloy which is made up of tin and copper, and this is an alloy which is having a low melting point. So it is always connected in series with the electrical circuit. Whenever there is an excessive current flows, so when excessive current flows in any household circuit, then the thin fuse wire gets too much heated and it melts and breaks the circuit immediately. So due to excessive current, this, because as it is having low melting point, so it melts and it breaks the circuit, and thus it can stop the flowing current. So due to this, the damage to various electrical appliances can be prevented. So when a fuse gets melted, a new fuse has to be fitted in its place to restore the electric again in the household circuit. So we can say this electric fuse can prevent the damage to our electrical appliances. Now next, here we will discuss about causes of excessive flow of current. We know that sometimes excessive flow of current flows in household circuits. So this flow of large current can be because of two reasons or two circumstances. First is short circuit, second one is overloading. Now first we'll try to understand what is short circuit. Short circuit is a sudden flow of very large current due to direct contact of a live and a neutral wire. First we'll try to understand what are live and neutral wires. So we know that in all the circuits, cables and wires are there. So there are mainly three wires. These are live wire, neutral wire and earth wire. So whenever these live wires and neutral wire in any circuit touch each other due to defective wiring or due to damaged wiring, so when these two wires touch each other, so the resistance of the circuit becomes very low and large amount of current flows in it. So due to this large amount of current, it leads to short circuit, which can lead to fire also. Now next is overloading. What is overloading? Overloading is the overheating of electrical wiring in any circuit due to the flow of large current through it. So you all must have seen sometimes when we connect too many electrical appliances to a single socket, then they draw extremely large current from the household circuit. So due to this, the wiring gets overheated, and this overheating of electrical wiring in any circuit due to large amount of current, it is known as overloading. So this overloading, excessive overloading for a long time can also lead to fires. Now next is magnetic effect of electric current. We have already studied about heating effects of electric current. Now we will discuss magnetic effects of electric current. When electric current passes through a wire, the current carrying wire behaves like a magnet, and it produces a magnetic field around it. So this is known as magnetic effect of current. A Danish scientist, Hans Christian Ørsted, was the first person to notice the deflection of compass needle every time the current was passed through the wire. So this was how magnetic effect of current was introduced. Next is solenoid. Now, what is solenoid? Solenoid is a cylindrical coil of wire, and when current passes through this solenoid, it behaves like a bar magnet. Means magnetic field develops around the coil and it behaves as a magnet. Now next here we will discuss is electromagnet. A magnet produced by passing an electric current through a coil of insulated wire wound around a soft iron rod is called an electromagnet. As we have already discussed, solenoid is a coil, cylindrical coil of wire. So when we insert a soft iron core inside that wire or inside the solenoid, so the magnetic power of this increases and it creates a stronger magnet than the coil alone, and this magnet its magnet is disappears when you switch off the electric current. So we can say the magnet is of an electromagnet lasts only till a current passes through its coil. The strength of an electromagnet can be increased by increasing the number of turns in the coil. Means if we increase the number of turns in the coil, so the strength of the electromagnet will be increased, and we can also increase the strength of electromagnet by increasing the current passing through the coil or through the solenoid. Now, what are advantages of electromagnets over permanent magnets? The magnetism of an electromagnet can be switched on or switched off as desired. So this is not possible with a permanent magnet, and an electromagnet can be made very strong by increasing the number of turns and the amount of current passing through the coil. So this way electromagnets are more useful than permanent magnets, and on the other hand, permanent magnet cannot be made so strong. We can say electromagnets are more useful than permanent magnets. Now let us discuss uses of electromagnets. Electromagnets are used in motors that drive fans, mixers, washing machines, etc. And electromagnets are also used in cranes. These are used to lift heavy loads like big machines, steel girders, and scrap iron objects for loading and unloading purposes. Electromagnets are also used to separate magnetic materials like iron and steel object from heap of junk metal scrap. Electromagnets are used by doctors to remove tiny iron particles from the eyes of a person. And electromagnets are also used in electric bells, telegraphs, telephone, instruments, and loudspeakers. Now next is electric bell. An electric bell works on the magnetic effect of current. As we have already discussed that electromagnet is used in electric bell, so it has electromagnet in it. So now let us discuss construction of an electric bell. An electric bell has a U-shaped electromagnet. A small iron bar called armature is held in front of the poles, and the lower end of the armature is attached to a flat spring, and spring is itself fixed to a metal bracket, and the upper end of the armature has a hammer attached to it. There is a contact screw which just touches the armature at point E. A metal gong is fixed near the hammer, and the electromagnet is connected to a battery, a push button switch, and the armature in a circuit. Now let us try to understand working of electric bell. So when we press the switch, the electric circuit of the bell is completed and current passes through the coil of the electromagnet, and it gets magnetized, and this electromagnet attracts the armature towards itself, and this hammer attached to it strikes the gong and produces a sound. When the armature moves towards the magnet, its contact with the contact screw is broken, and due to this the electric circuit breaks and no current flows in the electromagnet coil. So the electromagnet loses its magnetism and the armature is no longer attracted by it. So the spring brings back the armature to its original position and the hammer moves away from the gong. As soon as the armature comes back and touches the contact screw, the circuit is complete and the current starts flowing in the electromagnet coil again. So this process of make and break of the electric circuit occurs when you press the switch. So this is how the hammer strikes the gong rapidly, producing almost continuous sounds. So this is how bell rings. So this was the working of electric bell. So we have seen that this electric bell works on the principle of magnetic effect of current, and in this chapter we studied heating effect of current as well as magnetic effect of current. So this was the last topic of this chapter. Thank you.